we're live. Thanks, thanks everyone for attending our first event of the year. So we're starting again with our online events. Hopefully at some point, I really miss the in-person events, but right now, this is the best we can get. So let me share my screen, just some general announcements. Okay, I think we can look at that. So we're the Charlotte Java user group. This is the places where you can find us. One thing that I like to stress is that it's a community for everyone. We embrace everyone, and not only as a attendee, but also if you want to participate in any capacity, just reach out to us. If you want to give a talk, if you want to get more involved, if you have an idea, suggestion, if we're messing things up, let us know. We want to make this community every time better, and definitely for that we need your feedback. So this is the places where you can find us. If you're on Twitter, please follow us. If subscribe to our YouTube channel. All of these presentations will be not only streamed on YouTube, but also available for later view if you want to share this with any of your co-workers or friends. And this email, in case you want to send us a note, especially for our next topic, which is our JetBrains license raffle. So we're going to raffle. Our friends at JetBrains are one of our sponsors, and they provide us with a license that we're going to raffle at the end of the presentation. So Dan will make a question related to the topic, so pay attention, and whoever responds first on the live stream chat gets one license for one JetBrains product. So that's pretty cool. I'm gonna pass it over to Abel, but I mean, I just want to thank Dan for doing us the favor of presenting this topic that I think it's really important to understand. Sometimes we just talk about jobs, passing around jobs, but with little understanding of what they are and how and the ways that we should be using it. So I'm really glad that we have Dan today to give us a talk about this. But I'm going to pass it over to Abel right now.
Thanks, Orlando, and welcome to the people that is online watching the stream. First event of the year, like Orlando said. Hopefully, it's going to be a better year. Also, waiting for the time when we can again do events in person. So today we have a quick announcement from Slalom Build. Colin is with us to give us some information about Slalom and some opportunities for the Java community. Colin?
Thanks, Abel. I'm going to go live and share my screen. Perfect. So thank you for allowing me to kind of chime in and share a little bit about Slalom and Slalom Build's footprint, not only here in Charlotte, but kind of on a larger scale. So for those of you who aren't aware of the brand and the organization itself, we launched back in 2001 out in Seattle and have organically grown over the last 2 decades to about 35 different markets, primarily in North America, but we have started to grow our presence in Southeast Asia and Australia and the UK. So while we are a mid-market kind of consultancy in terms of size at about 8,000 people, 1,200 of those fall within our technology consulting arm, which probably applies mostly to this group. And when I say that arm, that's what we refer to internally as kind of those builders and those product engineering masterminds. And we've had a lot of fun since about 2011, just partnering with clients, variety of industries and technology stacks and challenges that we're overcoming, and basically taking an idea and going through each stage and kind of bringing that to life. And at the end of the day, our goal is to exceed that, that level of or threshold of quality for our clients. So we kind of have 3 different pillars when it comes to the strategy, technology, and then transformation elements. We want to be along for the ride, but at the end of the day, enable those specific environments to be able to maintain, or those teams to maintain the products that we build. So great opportunity if you're someone that constantly likes to kind of grow and learn and tinker around with new technologies. And within Charlotte, we have 6 different teams that kind of fall in that build umbrella. Our software engineering team, data engineering, cloud DevOps and security, our test automation architects that fall in that quality engineering team. And then we have experienced designers, a full stack UI UX group. And then last but not least, our solution ownership team, that they're kind of the glue that act as that product owner, BA, PM throughout that agile build out or those different sprints. So just wanted to kind of share a little bit more about us, because we're 2 years new or old, however you want to phrase that, in the Charlotte area. And just, for those of you who aren't aware of kind of consultancy and kind of the fun that you can have with taking on new challenges, I feel like we do a really good job of marrying the 2 concepts of the autonomy that you would get at a tech startup with those challenges, but also having the stability and not the risk of funding falling through and that type of thing. So I posted our careers page on and kind of on the meetup chat and some of those links for anyone who wants to reference that. But really, we grew really quick out of the gate in our engineering team, and there's some overlap in terms of needs when it comes to data architects, cloud DevOps, security experts, and so on and so forth. But we're constantly entertaining conversations, and we want to build a home here and continue to plant roots in the community. So feel free to reach out to me on LinkedIn or however is easiest if you want to learn a little bit more. But that's all I had for the group, and I really appreciate a few minutes to share some insight on us, and I can stick around for any questions if needed.
Thanks, Colin. And yeah, well, that was, well, I think we are ready for the presentation. Dan, we'll hand it over to you. Thank you. Thanks, Colin.
And feel free to send questions on the live stream. We'll be passing those questions to Dan as soon as we get them. And please be patient. There's a slight delay on YouTube, like 5 seconds. So just wanted to mention that. But go ahead, Dan.
Let me unmute myself. Great, thank you. So today I'm talking about JWTs, what Java developers need to know. 2 things I wanted to kind of throw up before I even started are first, Solemn, great company. They're actually I'm in Colorado, so they're in the Denver area too, and really appreciate their sponsoring. And I started out a consulting company, and it's a great way to get a breadth of experience and see a ton of different interesting domains. So highly recommend talking to them if you have a chance. The second thing is, this is something that Orlando alluded to. I help run a meetup in Colorado, and we're always looking for speakers. So meetups I've found are a really friendly audience. And if you are terrified of public speaking, or you just want to brush up on it, we're your people here, right? And so I highly encourage you to reach out to the organizers. I had a great experience with them getting this set up, and I would just encourage you to help foster the community by speaking about something. And I've had people talk at my meetup about something as small as a 5 to 10 minute talk about one particular technology problem they solved and how they did it. I don't know whether that's your format here, but talk to the organizers if you have any interest at all, would be my pitch. All right, done pitching with that. So now we're going to talk about JWTs. And sorry, I had one more pitch, and then I promise this is the only pitch slide about my employer in the entire presentation. FusionAuth is my employer. We're a drop-in user data store. You can think of us as something similar to Okta or Auth0. We have different levels of software. Our community edition is almost 100% of the features in the other editions. There are a few premium things we hold back, but you can use it. The Community Edition supports multiple different OAuth grants, SAML integrations, passwordless, MFA, consent. It has a consent model. It supports family relationships, so you can model like things that conform to COPPA, which is the Children's Online Privacy Protection Act. So all that's to say is if you are looking for a user data store, user management, please check out FusionAuth. Now, how it's germane to this talk is that in the course of building FusionAuth and running FusionAuth, we produce a whole lot of JWTs. About me, got to have the obligatory About Me slide. Actually, who cares? You're not here to learn about Dan Moore. You're here to learn about JSON Web Tokens. So if you have questions, you actually can't ask with your voice. Sorry, I needed to update the slide, but go ahead and ask on YouTube and the moderators will kind of jump in and tell me whether or not, ask me the question. So I do prefer for conversations and presentations to be, more of a discussion or a conversation. So if I say something that's outrageous or questionable or just piques your interest, feel free to watch it on, ask the question on the chat. I unfortunately don't have the chat open. I can't really have my eyes in two places at one time, but the moderators have said they'll pipe in with any questions. So to the meat of the presentation. So JSON Web Tokens are pronounced JWTs. I don't know whether you've heard this before. It took me a while to get used to it because I'm used to saying JWTs, but they are standard. And what JWTs are really good for is stateless portable tokens of identity. And we'll talk more about like what that means and what the problem that is to solve. But if you take only one thing away from this presentation, I would say understanding that a JWT is a stateless portable token of identity is the right thing. This means that they're great for APIs because you can basically have one server or service generate a JWT, and then it can get passed to a client. And that client can present it to different APIs, and those APIs can rest assured that that client is who it says it is. They're produced by in most cases, they're produced by many identity provider servers, and they're often used as bearer tokens in the world, especially around APIs. So here's, I'm going to walk through kind of a scenario of like why you might choose to use a JWT. So we're going to have a kind of distributed application with it's a to-do application. So, and it's not going to be a complicated to-do application. It's going to have to-dos and it's going to have users. And you can have multiple different clients, web clients, mobile clients, other kinds of clients. User API looks pretty standard, right? Just roles and users. Your to-do API just stores to-dos. Now, in a monolithic application that wasn't distributed, you would have a to-dos table that might have a user ID in it, like this. But in a distributed application, this user ID, obviously, we still need to kind of have some reference to a user. Otherwise, we couldn't tell whose to-dos we were supposed to display. But it's not going to be able to be a foreign key like it might be in a more typical kind of monolithic application with one data store. So what's the kind of the flow here? The flow is we have a client. They're going to authenticate the user somehow. Typically, it's going to be username and password, but it could be any kind of credentials, WebAuthn or something like that. And the user API is going to perform that authentication and hand back some user data, right? So the user data might be some JSON that might look a little bit like this. So it's going to have user information, an ID, other kind of metadata about this user, their email address, what roles they might have. For this to-do application, we don't need anything else. But if we're building a more complicated one, we might have a kind of user level, right? Like, are they a paid user? Are they not a paid user? Other information that the client might need to display. So then the client is going to pass that user ID up to the to-do API, which is going to look up the to-dos for this user and then pass back the to-do JSON. And then that client can now represent that however it wants, right? If it's a mobile device like it is here, then it'll probably be building, mobile widgets. If it's a web application, it might be building HTML, or if it's a spa, it might be building, a DOM. It doesn't really matter what it is. We don't care. But obviously, I'm sure that you all saw the problem with this approach, right? The issue is that a malicious client might notice that, hey, I'm user ID 42 and I passed in user ID equals 42 and I got back my to-dos. I wonder what would happen if I pass user ID 1. And then you obviously have this huge issue where people can, a malicious client can like search out other people's to-dos, right? And very important that my my task tonight to go get milk after work is remain safe and secret with me. I joke about that, but obviously if you're building any kind of service at all, you want to make sure that user security is kind of built in from the ground up. So one approach that you could take to remediate this would be to use an opaque token. So in this case, the user API hands back inside the user object a token. And that token is what gets passed to the API. So it's no longer this ID equals 42 that identifies the user. It's an opaque token, which could be a random string of digits and numbers, right? We don't really care what that token is. What we care is that token has certain properties, that it's going to be unique to the user. We need that. And then we also want to make sure it's not iterable or decodable in any way. Then what happens is the to-do API takes that token and calls into the user API and gets back all the data it needs, whether that's the entire user object is JSON or just the ID. Those are implementation details. You can choose how to implement that. Then once it gets back whatever identifier it needs, it goes and looks in the to-dos table and grabs the user's to-dos and then sends them back to the client for the client to display. All right, we've remediated this problem of a malicious client being able to iterate everybody's to-dos. That's a great start. Every approach has its strengths and weaknesses. So let's talk a little bit about this approach. So some of the problems with this approach are that you have to kind of maintain this user token mapping. And maybe problems is too strong a word. Some of the attributes of this approach are that you have to maintain that mapping. You have to do that either in the database or in memory, and both those have trade-offs, right? It also makes the user API stateful. And one of the bigger things I would say is kind of drawbacks is that it can be chatty and it couples the user API to everything. And not just coupling in terms of like a data coupling, but in terms of actually the to-do API needs to be able to talk to the user API every time it gets one of those tokens. So it's actually a kind of a runtime coupling. It's not just that there's a data share between the two. It's actually that every time the to-do API gets one of those tokens, it needs to talk to the user API. Now, of course, you can introduce some caching, right? You could put a cache layer right in here, and the to-do API could only request that token once, and it only make that request to the user API if it didn't exist in the cache. But in any event, you're really depending on the user API being up and available. So this is where JWTs come into play. So again, JWTs are a portable stateless token of identity. And so in this particular case, the user API will generate a JWT and it will sign it. And we'll talk more about what signing means in a little bit. But it will pass that JWT down with the user data. And frankly, the user data could actually be entirely encapsulated within the JWT. That's, again, another implementation detail. But the client then will pass that JWT up to the to-do API. The to-do API can decode that JWT and verify that that JWT is as it expects it to be. And then it will basically extract that same user ID and be able to look in the to-dos database. So two things that are kind of worth emphasizing here are that the user API needs to sign a JWT so that the to-do API can be assured that the user API actually created it, and that the to-do API actually doesn't need to talk to the user API once it receives the JWT. So those are kind of the two big wins of JWTs over the opaque token, are that the to-do API is at the same time assured that the user API created the JWT and doesn't need to talk to the user API to verify any user information. As far as signing, we can talk about it can be signed as a public-private with a public, it can be signed on the user API side by a private key and then verified with a public key, or you can use a symmetric key. And we'll talk about in a little while about which one makes sense to choose. And the other thing that is useful is that it can contain all kinds of metadata. So unlike the opaque token, which is really tied, was a kind of a value without any meaning, JWTs can contain arbitrary data. So let's go ahead and look at JWTs. Look at a JWT. So this is a real live JWT. If you, and I can make the presentation available afterwards. If you were to kind of cut and paste this and put it into a JWT debugger out there, you would see real live things. So not faking it here, folks. There are three parts to every JWT. There is the green part, which is the header. There's the blue part, which is the payload. And then there's the tan part, which is the signature. And so they're all separated by periods, by full stops. And each of these is URL in, base64 encoded. And the main reason that they do that is that JWTs can contain all kinds of interesting characters, curly braces, double quotes, other things. And we want to make sure that a JWT can be put in a lot of different places. One that jumps to mind is the authorization header, right? Again, if you're using it as a bearer token, which is a common use case, headers tend to not like special weird characters. And so that's why it's all base64 encoded. So this is the header from that JWT. And basically the header contains metadata information. In this particular case, we're saying that this JWT was signed with the algorithm of it's an HMAC 256 algorithm. The payload is your business data, right? This is the things that are actually interesting. And what this looks like is a JSON object. The keys to this JSON object are called claims. And that's just kind of a bit of authentication jargon. And there are standardized claims that are defined in the RFC. And then there are other claims that aren't defined in the RFC. And anything that's not defined in the RFC, you can kind of put in under whatever key you want. Now, the standardized claims, the meaning of them is defined, but the actual values are less well defined. So the first four here, ISS, EXP, AUD, and SUB, are all standardized claims. ISS is the issuer. So that is who created this JWT. EXP is the expiration time, and that is one where the value of it is defined. It needs to be the number of seconds since the Unix epoch after which this JWT will expire and no longer be valid. We have the odd, which is either a string or an array of strings that is who this JWT is intended for. And then the sub is who this JWT is about. Now, at FusionAuth, we do those as GWIDs, but there's no reason you have to do those as GWIDs other than it being a generally good idea to use a GWID. You could use an arbitrary string. You could use an integer if you wanted. It doesn't really matter what those values are as long as they refer to an entity that your producers of the JWTs know about and your consumers of the JWTs know about. Name and roles are non-standardized claims. And then finally, we have the JWT signature. Nothing super special about this. There's a variety of different algorithms you can choose to use. The two main differentiating factors are whether it's a symmetric algorithm or a public-private key algorithm. And the main reason why you choose one over the other is, wait, I'm going to save that for a later slide. Just kidding. So finally, you get the user ID, you get the subject ID, and you can now look that the to-do API has decoded that JOT, has verified that everything is as expected, and now can pull from the to-dos database for user ID, user 42's to-dos. So I'm going to pause for a second, have a drink of water, and if you have any questions in the YouTube chat, feel free to type them in. Otherwise, after I take a little break, we'll get going. I was informed there was a bit of a lag, so.
Yeah, no questions so far.
Great.
From what I can see.
Awesome. Thanks. All right. So we kind of talked about why you might choose a JOT over some other options of identity in a distributed system. Let's talk about, and we've kind of examined what a JOT is in terms of like the pieces of it. So let's talk about some issues that you may run into with a JOT. And every time I post this on Reddit or Hacker News, or I post about JOTs, or anybody else posts about JOTs on Reddit or Hacker News, people come out of the woodwork and say, it's horrible, don't use them. You know, why would you ever use them? And I'm the first to say that it's a standard, and it's a standard that gives you a lot of different options. And so you need to be an engineer when you're choosing, how to build these JOTs or how to consume them. So my first bit of advice is, given all these different configuration options, use a library. And there's no reason in my mind that you should be not using a library to consume a JOT or to boost a JOT these days. There are a number of different open source libraries out there for Java that you can pull into your project under a variety of different licenses. Most other languages, if you're working in other languages, have a library. So please use a library. The second thing is, make sure you verify your claims. And this includes not just the expiration claim, which we saw earlier, but the audience claim and the issuer claim. So you want to make sure that those are both values that you expect. So when you're pulling out that JOT as a consumer, again, don't rely on the library to do all your verification. Actually look at that JSON object and say, okay, this is the issuer that I expected. And and I am part of the audience that this JOT was created for. Otherwise, throw up your hands and return like a 403 not authorized or a 404 not found, whatever the appropriate HTTP status code is. Another thing to be aware of is that they can contain arbitrary JSON, which we kind of saw earlier, but there's no secrets involved. This is most JOTs. Now, there may be some people who are JOT experts here who may say, wait, there are encrypted JOTs, and there are. I'm talking about signed JOTs. So there's two differentiating things. There's signed JOTs, which are what we just examined, where you have the signature. There's also encrypted JOTs where the actual payload is encrypted. In that case, it's okay to ship secrets around. I'm not as familiar with those kind of JOTs. Signed JOTs, there are no secrets. It's like you're putting something on a postcard. So that's why big fans of GWTs instead of using integer IDs, because you can actually leak data when you're passing around an integer ID, because that, I guess, depends on what your implementation is like, but typically integer IDs are auto-incrementing, which means if you have an integer ID of 42, a bad person who is looking at a JOT, who has somehow get their hands on a JOT, might know that there's, might be interested in user ID 41 or user ID 40. And the other thing to be aware of is, if you are using the symmetric signing algorithm, then you want to make sure you pick a nice long random key. Otherwise, you can have a situation where the key is actually can be brute forced. There's actually C code out there. There's an open source C library or C program out there that can brute force an HMAC key from nothing other than the signed JOT. Now, I think when I played around with it, it took like, I don't know, 20 seconds with a 4-character HMAC key. So, you can make it sufficiently long and be okay with that, but make sure it's a nice random key. You also want to make sure that when you're using JWTs as an access token, that you're storing them carefully. So because they are often used as bearer tokens, that means that someone that is a malicious actor can, if they find your JWT, either by an XSS attack or in some log file or in a cache, like somehow it got cached, right? If it was used as part of a get string, which is not a good idea, but can happen, then they can take that JWT and present it to the Do API, and that Do API will not know that it is not the original user. And so this is where the expiration time makes sense, right? That's why you want JWTs to be fairly short-lived. And then there are actually solutions out there to have tokens that are sender constrained. But those, as far as I know, are not really widely deployed. So in general, you should treat a JWT as kind of a piece of privileged information, and be careful what you do with it, because it's you can think of it like an like a short-lived API key, right? That's tied, that bears information about an entity. And you wouldn't check an API key into GitHub. You should be careful with your JWTs too, even though they're not as bad. Losing a JWT is not as bad as losing an API key because it is time constrained. As far as your token storage, at FusionAuth, we recommend you store it server side if at all possible. If you do need to push it to your client, use an HTTP only cookie on the browser, or if you are pushing it to a mobile client, use secure storage. Another big foot gun that always comes out when people are hating on JWTs is the none signing algorithm. And so the idea is that the JWT specification allows you to have to not sign your JWTs. And so what that does is that transforms the JWT from looking like this to looking like this. So you can see that the third clause is entirely gone. And so it changes the header from something like this to something like this, where the algorithm used to sign the JWT is none. And so you end up with something like this. And the specification allows us. This means that if your consumer accepts unsigned JWTs, that means that anybody can sign a JWT with whatever payload they want, or create a JWT with any payload they want, and send it to your consumer, and it'll be treated as if it came from a valid creator of a JWT. That typically is a bad idea, right? That's like saying, that's like basically having a password of the string password, right? Anybody can get in. Or actually, it's even worse, it's having no password. So the simple fix is don't ever allow none, right? If your JWT consumer ever sees an algorithm of none, or an algorithm of none, then it should just throw up its hands and say, hey, I'm not going to take this. Now, I have been a consultant, as I mentioned earlier, and the answer is always it depends. There are some use cases where algorithm none makes sense. And so the ways that you can verify that all take place outside of the JWT, the normal kind of use case, right? They happen at the network level, or there's some other way of doing this, right? So mutual TLS or client certificates is one way where you can make sure that the presenter of the JWT is actually who you think they are, because it's happening at a layer underneath the JWT. Another way you could do this that I have never actually seen, but could conceive of you doing so, would be if you had a private network, right? If you were like on a private VPC up in AWS or in some other cloud or in your data center, and you needed JWTs to be passed around to verify who was who, but it never had any connection with the internet. And so you could be assured that there'd be no bad actors on that particular network. In that case, if you have that kind of isolation and or other client verification, and you've done the testing to know that signing JWTs is enough of a performance impact that you should explore the algorithm none option, then go for it. Again, it's a complicated standard, and they try to cover a lot of different use cases. But in general, 99% of the time, you should just use a signed a JWT with a real signature. So as promised, I'm going to talk a little bit about public-private key pairs. And the main reason why you'd be interested in using public-private key pairs is that there's no shared secret. And so when we look back at the To-Do API, with we have the user API and the To-Do API, they have to share some kind of secret if you're using a symmetric signing algorithm, because the To-Do API the user API signs the JWT with the key, and then because it's symmetric, the To-Do API needs to have access to that same key to verify that it was signed by the user API. So if you don't have that shared secret, you can scale organizationally. When you have 10, 20, 30, 100 different APIs, you may want to not have to distribute some shared secret whenever you are rotating your signing keys, or whenever you are deploying some new kind of piece of code. The other thing that is important about avoiding a shared secret is that it makes things more secure. And the reason for that is that when that To-Do API has that shared secret, whatever the string is, if someone else can break into the To-Do API and get that secret, they can now sign JWTs that are indistinguishable from those that are created by the user API. So that could be problematic. Key rotation is easier with public-private key pair because you can also support multiple keys, so you can have multiple valid keys happen kind of at the same time. However, there isn't no such thing as a free lunch. It's a little more complicated to understand public-private key pair signing, and then it's slower. That's probably the bigger issue. Depends. Obviously, you should always benchmark your particular situation. I saw it being a 2 to 5 times slower last time I looked, but it is going to depend on kind of the JWT implementation, the language you're running in, how big your JWTs are, how long your keys are, things like that. All right, so if you're going to have public-private key pair, basically how it goes down is the user API signs the JWT with the private key, and then passes, again, the user containing the JWT, the user information containing the JWT down to the user API. That JWT's passed back up. The To-Do API now needs to get the public key to verify this JWT. And so it could either have the public key stored locally, or it can reach out to a well-known endpoint. And this particular one is the FusionAuth endpoint, but there's actually a standardized one. If you search for JWTs, you can see that there's actually a well-known endpoint that public keys are published at. And then the To-Do API can retrieve that public key and then do the verification. So this is what that endpoint might look like. Again, it's just an RSA. In this particular case, it's an RSA public key. If you have more than one key, as alluded to earlier, basically the entity signing the key basically needs to add the key ID to the header, and then the consumer is responsible for looking up the correct key to verify that the key was signed by the corresponding private key. Refresh tokens are a key part of any JWT strategy. So as I mentioned earlier, because they're bearer tokens and because they're stateless portable tokens of identity, they really should be short-lived. And we're talking about seconds or minutes, maybe hours, depending on your use case. Refresh tokens, however, can be longer lived. And so a refresh token can be presented to the entity that created the JWT and then gets a new JWT. So a client will take a refresh token and present it to the entity that created the JWT and then can get a new JWT in return. Let's kind of see how that looks in a diagram in a second or two. But the reason why refresh tokens make sense is that there's compromise. And the compromise that they are between is either the user authenticating an awful lot or a long-lived JWT. So on the one hand, if you have your JWTs be minutes or seconds in length, every time that JWT expires, you may have to force your user to re-authenticate, which obviously is not a great user experience and not something that anyone is really going to put up with. The other option is that you can make your JWT, without a refresh token, you can make your JWT good for days or weeks. But then if anybody gets a hold of that JWT, any nefarious actor, you're going to have this thing floating around. And we'll see in, I don't know, 5 or 10 slides how to revoke JWTs or how you can kind of work around them being stateless, but it's not easy. And so it's way better to make them short-lived. So here is what a refresh token might look like. Or sorry, the flow around a refresh token. So we have JWTs. We have the user API. The client has authenticated and whatnot. The user API passes down a JWT and a refresh token. The client presents the JWT repeatedly to the JWT API. The JWT API looks at it, validates all the claims, makes sure it hasn't expired, makes sure that the issuer is correct, the audience is who it's intended to be, etc. Does all those checks, and then serves back the to-dos. At some point, this JWT will expire, right? Let's say it happens in 5 minutes. So after 5 minutes have passed, the client presents the JWT again because it needs to get the to-dos again. The to-do says, whoa, no way, you've expired, and returns back some kind of error message. The client can catch that error message and say, okay, this JWT is no longer valid. Do I have a refresh token? Oh, I do. Excellent. I'm going to present that refresh token to the user API, and hopefully it will give me a fresh JWT. And the user API can check to see that the user hasn't logged out, that the user's account hasn't been disabled, or whatever checks need to happen. And then it can create a new JWT, good for another 5 minutes, and pass that back to the client. And refresh tokens, again, can be held for a long time. There are various other strategies you can do, right? You could have a new refresh token get created every time. It really depends on your security posture. But the point is that refresh tokens allow the client to continue to make to-do API requests after that initial JWT has expired without forcing the user to re-authenticate and to give their credentials again. Now we're going to talk about some other aspects of a distributed system that you might use along with JSON Web Tokens. So traditionally in a monolithic application, if you were deleting users because someone said, hey, I don't want this account anymore, and you really want to be able to do this, right? Because you want to be able to do this thoroughly, because GDPR, CCPA, there are rules now around people being, users being able to say, hey, I want you to delete all my data. And if you don't do that, there can be problems for you in your company. So in a monolithic application, you might do something like this, right? Where you say delete from users, where the user ID equals a certain number, and then cascade, delete all of the rows that have foreign keys into this user's table. Unfortunately, in a distributed system, you don't have on delete cascade. So you have a couple of different options. You can push the complexity of the client and force it to make a delete call across all the different APIs, which is one approach. There are issues with this approach because if you add another API and you have an older version of the client, it might not be able to correctly call all the appropriate deletes. You also might have a situation where the client has an intermittent network connection, and so it's able to call this first delete, but not the second one. So I'm a big fan of pushing complexity to the server. And so in this particular case, you call one delete, and then the user API basically fires off webhooks to any interested parties that want to know about this user being deleted. And so that could be the to-do API, it could be an email API, any other APIs that you've added around here. They're responsible for saying, hey, let me know when a user's been deleted. And then they can take care of the cleanup, right? They can delete all the to-dos that the user has created. Anytime you talk about authentication, which is kind of tied in with JWTs, you want to think about logging out. And with JWTs, your option for log out is really to revoke the refresh token. Again, in a couple slides, I'll talk about how you can semi-revoke JWTs, but you want to make sure that you delete the refresh token. It might look a little bit something like this. The user logs out. The client can delete the JWT, right? So that it can remove it from secure storage or wherever it has stored. You can, as part of the logout process, if this is a browser, you can delete the cookie. You also should delete the refresh token from the client, and as part of the logout process, you should make sure that you are destroying or marking invalid the refresh token. You also want to make sure that you log out, if you have multiple different refresh tokens, because it's conceivable you could have different sessions going on. You want to make sure you revoke all of them. Now, can you revoke JWTs? This is a common question we get. And the answer is sort of, kind of. If you have a situation where a user's account has been breached and you really want to make sure that, all the JSON Web Tokens that are associated with that user's account are now invalid, you could do something like rotate keys. And so if you're going to rotate a key and make all of the previous keys invalid, then you're really kind of lighting a fire, right? You're really, destroying a lot of people's valid JWTs to make sure that one JWT or set of JWTs is not valid. And so it's a big choice, but if it's like an admin user's account who's been breached, it's possible that could make sense. Another option is to use what we call the time window solution. And so what this does is this takes advantage of the fact that JWTs tend to be created for a standard length of time. And we can also, in the same way we had a webhook for a user deletion event, we can have a webhook for a user logout event, right? Or a refresh token revocation event. And so in that case, the to API now keeps a cache of JWTs that are of users who've been logged out, right? And it can key it off of that sub ID or that sub claim. And then when the JWT comes in, right, if it's been stolen or somebody else has it and it gets presented to the to API, the to API can check that cache and say, okay, cool, this sub actually has been logged out, so I'm going to treat this as invalid. Now, you want to make sure you do it over a certain time span because you want to handle the case of someone logging out and then, that revocation happening, and then 5 minutes later or 2 minutes later, they log back in. You don't want that second that second JWT to be invalid. So let's kind of talk about how you do that from a time-based situation. Let's assume that the JWTs are good for 30 minutes. If it is 1:12:47 right now on this particular date, then if we create a JWT for 30 minutes from now. It's going to be good until 1:42:47. That means that a jot created 1 second ago will expire at 1:42:46. Let's say that we want all jots that were created before 1:12:47 to be invalid. So basically, that would mean that all jots that expire before 1:12:46 are invalid because there's that 30-minute window. So basically what we're doing is we are taking care of this red area by saying, and again, this is additional logic you have to implement. We have a sample solution on our website. This is not kind of part of the standard or anything like that. This is just a way for you to take advantage of the time boundedness of jots to deal with this red zone where typically a jot would still be valid because again, it's a stateless portable token of identity. This is a way of introducing state back in. Real quick code. I'm not going to go through all this since I think I'm running a little bit long, but I wanted to show you that this is just a set of Java code that uses an open source library to create some jots. So basically, I'm creating a signer on line 19. You can see that's a horrible secret. Please don't use that secret. And then I am setting some claims on my jot. And not just standard claims, but on lines 28 and 29, I'm adding in some custom claims. And I'm going to encode them. And I'm going to print out the encoded jot. And again, from line 16 to line 34 is all kind of playing the role of user API. And again, this may be something that you use a separate identity provider for, whether it's FusionAuth, or Auth0, or Okta, or what have you. And then lines 36 on, we're actually adding we're doing the verification. And so again, here you can see that the secret on line 37, the secret needs to be shared, and we are going to decode it. So you can see that this jot is good for 5 minutes and it gets turned into this JSON object at the end. The other thing I wanted to show you is because I think it's really important to check claims, as I hopefully I've emphasized. And so here, this is exactly the same. I did some copy pasta, so it's exactly the same user API, but here's where I'm checking some claims in the consumer, right? So lines 39 on in the consumers, and this is kind of the to API. And here I'm picking both the audience and the issuer. And so if either of these are actually, I guess in this case, I am checking both. Great.
Hey, Dan.
Yes.
We have a question. Why we are using zone date time?
Why are you using zone date time?
Yeah.
I believe that the shots need to be in the in UTC, so you could use anything that you want that's going to generate that. Well, look at that real quick. I mean, you could have definitely done date.systemtime millis divided by 1,000 plus 600 if you wanted to. It doesn't really matter.
Okay.
Does that answer the question? I hope that answers the question.
Yeah. Let us know if that answer the question, or if you have any follow-ups on the chat, please.
And that I honestly, I haven't played around with this library too much, so it could be that that's just what this library expects, is this zone date time. But the JWT specification doesn't care.
Yeah, I think that's the case. I mean, it depends on what the library is expecting for that claim, for the expiration claim.
Yeah, I mean, yeah, the library should, at the end of the day, the claim should be, again, like, you know, this right here. But I don't think, I'm not sure that, yeah, I think you're right. It is probably library specific. Cool. Thank you for the question. So yeah, so down here we have, you know, the JWT API has these values that it's going to expect. And so it's going to check that those claims exist. And it should do that every time it receives a JWT. And let's change this to, oh, what did I do? Just so that we can see that, you know, exception handling still works in Java. There it is. So again, this stuff is available under the Apache license. You can grab it. There'll be a link in the presentation. So, all right. So as far as JWTs in Java, I think that the real question is what you're trying to accomplish. If you're kind of generating or parsing JWTs, I would say use a JWT library. There are many, many out there. FusionAuth provides one that's open source, that's kind of Apache licensed, but we're not the only people by any means. There's definitely ones out there from the other major auth providers, and there's other kind of free ones out there. As far as authorization goes, then I think that depending on what framework you're in, it depends on what framework you're in. If you are using a framework, right, DropWizard or Spring or whatnot, I would first see whether there's a JWT framework, a JWT consumption framework. I was working on a DropWizard example application a month or two ago, and it was very easy to pull in a library that was able to do that JWT parsing. And, you know, basically I tagged a resource with a role, and it took care of that matching process. So always look for the libraries if possible. For Spring, there's a JWT authentication provider, and I believe does that. JWT tools, we have a JWT debugger. Again, that's one among many. We have the link to the example JWT project I just showed you. I did write a couple thousand words on how to build a secure JWT from the perspective of the user API or the JWT creator, the JWT consumer, the JWT client. So if you're interested in learning more about JWTs, I'd suggest reading that. And then this is a article about how to set up JWT authentication and authorization in Spring. So I would just say thank you all for your time. I really appreciate that. And if you have any questions about JWTs or FusionAuth or you know, anything else, you can contact me here. Cool. So thank you. And is it time for me to ask the question?
Yeah. So it's time for the raffle. We have, like Orlando said at the beginning of the event, we have the JetBrains license, which is valid for one product for 1 year. And so yeah, Dan is gonna ask a question about the presentation. And for the people who is following the YouTube channel, just the first one to post the answer, the right answer that we confirmed with Dan, is gonna be the winner. And the only thing that we have to do is give us, you have to give us your contact information, and we'll send the license via email. So yeah, Orlando, anything else before we actually move to the question?
No, I think we can have the question. I have a question for Dan, but I think while we wait for the answer to his question, I can ask that.
Sure.
Sounds good.
Great. Okay. So my question is, how are JWTs encoded?
Nice.
Okay.
So while we wait for the answer on the YouTube chat, I have a question for you, Dan. When working with a SPA, and so we get the token, well, the JWT from our identity provider or user API in your example. What are your thoughts on where do we store that? Local storage, cookie, in memory?
Mm-hmm. Yeah. So I mean, the best way to store it is not to store it in the browser at all, right? Just because browsers have a huge attack surface. So the recommendation by default is create like a little proxy that that stores it on server side and then passes the session down. Now, lots of people who are doing Jamstack stuff can't do that, right? Sometimes it doesn't fit. So if you can't do that, HTTP only cookie is a really good option. Because that way, if there's any JavaScript, nefarious JavaScript in your browser, it can't access that. If you can't do that, I know there are plugins out there that can do kind of in-memory only options, but I don't know how supported across browsers they are. The one I saw was like a Chrome plugin. So,
Cool.
good question.
We have an answer from Vinod. He said that the encoding is base 64. Awesome. So we have a
All
win.
right. Awesome.
Awesome. Congrats.
So yeah, like we said, guys, if you have any questions, please feel free to post them in the YouTube channel while we're still here. Vinod, we're gonna, just if you can probably send us, send an email to info@cltjug.org, and we will send you the license to your email. So
Yeah.
it's info@cltjug.org.
Yeah, definitely don't put your email on the chat, but send us an email there.
You didn't tell me that. I just put my email on.
Concerns.
We need your email, your social, and your address.
Blood type. Yeah.
That's gonna be the most expensive license ever. I want to stress one thing that Dan mentioned about, this not related to JWTs, but about participating as a speaker. One thing that I didn't mention, you don't have to be an expert. That I thought about that for a long time before the first time I gave a talk, because I was expecting that I need to be an expert to talk about something. And we all do things at our work, and we get some level of expertise, on some level of knowledge. And that knowledge, we think that everyone has it, but no, so sharing that little that you know, there will be someone that will get value out of that. So don't hesitate if you have something that you're doing at work, something that you learn and you just want to share it. This is a great platform, and we can help you. If you need any help or tips, or if you want to do a practice run or anything like that, just definitely reach out.
Yeah, I would just say, again, I kind of already chimed in about this, but it's a great path if you want to speak at any conferences or anything like that. Start out with your meetup group, right? Because people know you, people are forgiving, and it's low pressure. I started out speaking at meetups years ago, and above and beyond just the help for the community, it's a good thing for you too, right? It helps you out. So.
Yep, I feel like one of the things that you start seeing immediately after you start speaking in meetups or conferences is your network starts to grow, and you actually have a lot of opportunities. You get to learn a lot and help other people learning a lot, which is awesome. So yeah, completely agree with you guys.
I want to plug really quick. I'm going to share my screen, Dan. So in February, there's this conference, DevNexus. I really encourage everyone to sign up. It is free. It's one of the best conferences that I have attended. It's in Atlanta, but right now, because of COVID, it's going to be completely online. Great speaker lineup. So there's very little reason not to register and attend. So I just wanted to quickly plug this in. And if we don't have any other questions, I just want to thank Dan again for doing this. Thanks for sharing. I think it was a really good talk. Like I said, I mean, a couple of years back, I was one of those people that I just heard the term JWT token passing around, and you're working on a library that already is introspecting the JWT. So sometimes you don't have to understand all the details, but I think it's really good because then you can leverage all the benefits and take care of those security measures like verifying signature and all the claims and all that type of stuff, which is really, really important. So thanks a lot again.
Thanks, Dan, and thank you guys at home. We'll see you in the next event.
Yeah, thanks everyone, and see you on the next one.
Bye.
Cool. And we're